All right, let's dive right in today. We're going to be talking about something you're bound to run into when you're building out a system with, a bunch of different services, like in a microservices architecture or something like that.
That's good.
And it's something that, if you bring it up and talk about it intelligently in an interview for like a senior software engineer position, it's a really great way to kind of, show off your understanding of good system design, right? And like how to build these systems to be really resilient and, maintainable and all those good things.
Yeah, makes sense.
So we're talking about avoiding unnecessary data transfer between your services.
Okay.
And specifically, a big part of that is this concept called pass-through coupling.
Yeah.
And I think that's something that, a lot of people may have encountered this, but they don't necessarily like have a name for it, right?
Yeah, absolutely. Like it's one of those things you see and you're like, that feels off, but you can't quite put your finger on why.
Exactly. So let's define this a little bit more carefully, right?
Yeah, sure.
So pass-through coupling, basically it happens when you've got one service, right?
Yeah.
And all it's doing is it gets some data. And it just passes that exact same data to another service somewhere else. It doesn't actually like use the data itself. It doesn't change the data. It just passes it along.
That's just a middleman, essentially.
Yeah, exactly. And it seems like harmless at first glance,
Right. You just think, okay, it's just passing it along. No big deal.
But as your system grows and, things start to change, it can actually introduce some pretty big problems.
Oh, absolutely. It can create a whole cascade of issues you wouldn't expect.
Yeah. It's all about those hidden dependencies and how a seemingly small change can ripple through your entire system.
So maybe let's ground this with like a real world kind of example.
Yeah, a good example always helps. So imagine we're working on like an e-commerce site, right? Something like Music Corp, let's say, selling, musical instruments and sheet music and all that.
Okay.
So somebody places an order on Music Corp. We've got our order processor service, right?
Right.
That's handling all the initial logic.
Got it.
Making sure the order's valid, handling the payment, all that good stuff.
Yeah.
Now, to actually ship the order out, it needs to talk to our warehouse service, right?
Makes sense.
Which is going to prepare the package and all that.
Yep.
And then the warehouse service relies on another service, the shipping service,
Right.
which is going to handle, like the actual delivery, through FedEx or UPS or whatever.
Got it. So you got your order processor, then the warehouse, and finally the shipping service.
Right.
Pretty standard flow for an e-commerce system.
So let's say the order processor, when it gets an order, it creates this like really detailed shipping manifest, right? And this manifest, it's got the customer's address, obviously. It's got like, what shipping speed they chose.
Okay.
And maybe even some like internal Music Corp order details. Who knows?
Interesting. So it's packing a lot of information into that manifest.
Yeah. Now, if the order processor sends this whole manifest to the warehouse, and then all the warehouse does is take that manifest and pass it directly to the shipping service, that's, classic pass-through coupling.
I see. So the warehouse is acting like that middleman we were talking about.
Yeah, like it's not really using that data for anything itself.
Just forwarding it along?
Yeah.
But I'm guessing this is where the problems start to creep in.
Yeah, exactly. So think about this, right? What if, later on, the shipping service says, hey, we need some new information on this manifest.
Yeah.
Like, we need you to include a specific tracking code format.
All right.
Or, we need a special handling instruction for, like, fragile items.
I could see how that would throw a wrench in things.
Because now, because of that pass-through coupling, the warehouse, even though it doesn't care about tracking code formats, now it has to be updated to handle this new version of the manifest.
Right, because it's just blindly passing it on to shipping.
Right. And then even further upstream, the order processor, which is the one that originally creates the manifest, now it has to be changed to include this new field.
Even though its main job is just processing the order, it now has to worry about this shipping-specific detail.
Yeah.
That doesn't seem very efficient or maintainable.
No, it's not. And it's, think about this, like multiple teams might be working on these different services, right?
Yeah, absolutely. You've got your order processor team, your warehouse team, your shipping team.
Right. So like a tiny little change in the shipping service could end up blocking deployments for the order processor team and the warehouse team.
Oh, wow. So that one small change is suddenly causing a huge bottleneck across multiple teams.
And it just makes everything slower and harder to change.
It really highlights how tightly coupled these services become because of that pass-through.
So essentially, the order processor, which is, way up at the beginning of the chain, suddenly needs to know about the data requirements of a service that's, two steps removed, the shipping service.
Yeah, that's not ideal. It means the order processor can't really evolve independently because it's tied to the specifics of the shipping service.
Right. So, you're going through your code, you spot this kind of pass-through coupling. What's the first thing that might come to mind to fix it?
Well, the most straightforward solution that might pop up is, hey, let's just get rid of the middleman.
Right. Just cut out the warehouse completely.
Exactly. Have the order processor talk directly to the shipping service.
Streamline it. Right.
On the surface, it sounds like a clean solution.
But, what do you think? Is that actually a good idea?
Well, it's not that simple, is it? While direct communication does remove that pass-through element, it introduces a whole new set of challenges. Think about it. If the order processor starts talking directly to the shipping service, it suddenly needs to know a lot more about how shipping works.
Yeah, it's not
Yeah.
just sending the address anymore.
Exactly. Before anything can be shipped, the warehouse needs to reserve that stock, right?
Uh-huh.
And then after it's shipped, the warehouse needs to update the stock levels.
So if the order processor is going around the warehouse for the shipping part, it might end up having to coordinate all this stock stuff with the warehouse directly.
Right. And on top of that, it's now also handling the shipping details with the shipping service.
So it's like we've just taken all this responsibility that used to be in the warehouse and dumped it onto the order processor.
Precisely. And that starts to blur the lines of what each service should be doing.
It also creates a pretty tight coupling between the order processor and the shipping service.
Yeah, suddenly the order processor is very dependent on how the shipping service works. And if the shipping service changes its APIs frequently, that could make the order processor really fragile.
So, okay, direct communication, not always the best solution.
Right. Sometimes it might work, but often it creates more problems than it solves.
What's a better way to handle this then? Like, how can we avoid this pass-through coupling without creating these new dependencies?
One approach that tends to work really well is to have that middleman, the warehouse in our case, take on a more active role.
Okay, so instead of just blindly passing data along.
Exactly. The idea is that the warehouse becomes responsible for constructing that shipping manifest itself.
Okay, so the order processor doesn't send the full manifest anymore.
Right. The order processor just sends the warehouse the essential information, like what item needs to be shipped, how many, and where it's going.
And then the warehouse takes that and creates the manifest in the exact format the shipping service is expecting.
Precisely. Think of it as a contract between the order processor and the warehouse. The order processor says, hey, I need these items shipped to this location, and the warehouse says, okay, I'll take care of the rest, including talking to the shipping service.
So the order processor doesn't need to know anything about the specific structure of the manifest or what the shipping service needs.
Exactly. That's all handled internally within the warehouse.
Now, what if the shipping service's requirements change? Like, let's say they need that customs declaration for international shipments now.
That's a great example. In this approach, as long as the warehouse can get that customs information, either because it already has it or the order processor starts providing it, the order processor itself doesn't need to know anything about the customs declaration or how it fits into the manifest.
So the change is basically contained within the warehouse.
Exactly. And the beauty of this is that it can even allow for more phased deployments. Remember how in the pass-through scenario, a change in shipping could block everyone?
Yeah.
Here, if the customs declaration is optional at first, the shipping service could roll out that change without immediately breaking the order processor or the warehouse. The warehouse could start including the customs information when it's available, and then later on, if it becomes mandatory, the order processor can be updated to provide it.
But even then, the order processor is still just interacting with the warehouse through their agreed-upon contract.
Exactly. It doesn't need to know why the warehouse needs that extra information or how it's being used for the shipping service.
So it's all about creating that layer of abstraction, right?
Precisely. The warehouse acts as a buffer, shielding the order processor from those low-level implementation details of the shipping service.
So it's more flexible, it's more maintainable, it's more resilient to change.
Exactly. It allows those services to evolve more independently, which is crucial in a complex system.
Now, you mentioned another approach earlier, something about treating the data as like a blob, was it?
Right. That's another strategy, and it has its own trade-offs.
How does that one work?
So in this scenario, the order processor still creates the shipping manifest,
Oh, okay.
but the warehouse doesn't actually look at the contents of the manifest at all.
Okay, so it just, like, receives this chunk of data and passes it along.
Exactly. It treats it as this opaque blob of information. It doesn't try to understand it, doesn't validate it. It just forwards it along to the shipping service.
So the warehouse is basically just a dumb pipe in this case?
Yeah, you could think of it that way. And this might be a good approach in very specific situations, like if the intermediary service truly has no business logic related to that data,
Hmm.
and if changes to the data structure are super rare and carefully controlled.
Okay, so like in our example, the warehouse wouldn't be able to do any checks on the shipping address or anything like that.
Right. It would just blindly pass it along.
What are the downsides of doing it this way?
Well, the main trade-off is that you're giving up any chance for the intermediary service to do anything useful with that data.
Hmm.
It can't validate it, it can't enrich it. It's purely a pass-through.
So like if we needed to add some logging or auditing of certain fields in the manifest, the warehouse wouldn't be able to do that.
Exactly. And if the shipping service ever needed different information than what's in that initial blob, you'd have to go back and change the order processor.
Okay, so it's simpler for the warehouse, but it's also less flexible.
Right. It's a trade-off between simplicity and flexibility.
So we've talked about a few different ways to deal with pass-through coupling. Direct communication, hiding details, the blob approach.
And it's important to remember that there's no one-size-fits-all solution.
Right. The best approach is going to depend on the specific details of your system.
Exactly. And this is actually a really important point for anyone who's getting ready for a senior software engineer interview.
Oh, how so?
Because being able to understand these different coupling scenarios and discuss the trade-offs of each approach, that's a really good way to show that you can think critically about system design.
It shows you're not just like reaching for the first solution that comes to mind.
Right. You're thinking about the long-term implications, the potential for changes down the road, the maintainability of the whole system.
So if you're in an interview and you can spot a potential issue like pass-through coupling, and then you can suggest a few different ways to fix it and explain the pros and cons of each, that really shows a senior level of thinking.
Absolutely. It demonstrates that you understand the nuances of distributed systems and you can make thoughtful architectural decisions.
I bet you've seen some examples of this in your own work, right?
Oh, yeah, definitely. I've worked on projects where the initial design was full of pass-through coupling, and it was a nightmare to make changes.
Like every time one service needed a new field, it was a huge domino effect.
Exactly. We ended up refactoring those systems to have the intermediary services handle the data transformation like we talked about.
To hide those downstream details.
Right. And it made a huge difference in terms of stability and independent deployments.
But I'm guessing you've also seen cases where, like, maybe the blob approach seemed like a good idea at first, but it didn't work out so well in the end.
Yeah, that happens too. Sometimes you think, oh, this is simple. Let's just treat it as a blob. But then later you realize, oh, we actually need to do some validation here, or we need to route this data differently based on its contents. And then you have to go back and redesign things.
So there's always a trade-off.
Always. There's no magic bullet. The key is to be aware of the different options and to choose the one that makes the most sense for your particular situation.
So for those of you who are listening and, you're prepping for interviews, I think a really good exercise would be to think back on the systems you've worked on.
Yeah, that's a great idea.
Have you seen examples of this kind of unnecessary data transfer?
Reflecting on your own experiences is one of the best ways to really internalize these concepts.
What were the consequences? Was it harder to develop new features? Was it a pain to deploy changes?
Yeah, and think about what solutions were implemented or what could have been done differently.
Exactly. Thinking through those real-world examples is going to be so valuable as you're prepping for those tough interview questions.
It will. It'll help you connect the dots between the theory and the practice, and it'll give you concrete examples to talk about in your interviews.
So to wrap things up today, we've talked about pass-through coupling, which is when a service just acts as a conduit for data.
We've explored a few strategies for dealing with it, each with its own strengths and weaknesses.
And the big takeaway, especially for those senior engineer interviews, is that understanding these coupling patterns and being able to talk about the trade-offs, that's a huge sign of your architectural expertise.
Absolutely. It shows you can design systems that are robust, scalable, and easy to maintain.
So as you continue your interview prep, here's a final thought. Think about all the systems you've worked on, all the distributed systems you've encountered. Where have you seen pass-through coupling? What were the consequences? And what alternative solutions could have been used?
Taking the time to analyze those past experiences is going to be super valuable.
It is. Thanks for diving deep with us.
It's been a pleasure.
And good luck with those interviews.
We got this.
All right, until next time.
See you then.